We want to analyze this series, 2n squared plus 3n divided by square root of 5 plus n to the fifth. This is n to the fifth, everybody. You can use comparison test or you can use limit comparison test. Both of them are absolutely fine. If you decide to use the comparison test method, you're basically comparing an and bn, and you have two cases. In the first case, case 1, if the larger series is convergent, you can conclude that the smaller series is convergent as well. And in the second case, case number 2, if the smaller series is divergent, then you can conclude that the larger series is divergent as well. Another method is limit comparison test. In the limit comparison test, you're trying to find a series that you already know how it behaves. Then they take the limit of general term of that series and this series that you have. As you take the limit when n goes to infinity, if this is equal to a number like c, which is positive and finite, then both series are convergent or both series are divergent. So your goal is to find something that you saw before. I try to remember a series that I saw before and I already know the behavior. So this is the trick. Students usually ask, what is the trick? How should we start? Remember a series that you saw before and you already know the behavior of that series. When it comes to series like this, general terms like this, try to simplify them. So when it comes to a series like this, when you see series as complicated as this series up here, try to simplify it. What's the meaning of that? It means that get rid of the terms with lower power. It means that get rid of the terms with lower power. So let me write down this series for you. This is the summation of 2n squared plus 3n divided by square root of 5 plus n to the fifth. N starts from 1, goes to infinity. When I say get rid of terms with lower power, I'm talking about between these two, you have 2n squared and you have 3n. 3n is of lower power than 2n squared. So get rid of it, just delete it, just erase it. The same for the denominator. Between 5 and n to the fifth, 5 is just a constant. So you can simplify this into the series of the form 2n squared plus divided by square root of 0 plus n to the fifth or n to the fifth. You can simplify this further. you get the summation of 2n squared divided by n to power 5 over 2, which can be written as the summation of 2 divided by n to 5 over 2 times n to power negative 2, which can be written as the summation of 2 divided by n to power 1 over 2. Well, what is this? This is something that I saw before? Yes, of course. This can be written as 2 times the summation of 1 divided by square root of n. This is basically a p-series. A p-series is the summation of 1 divided by n to power p, and starts from 1 to infinity. If p is more than 1, the series is convergent. If p is less than or equals to 1, it is divergent. P in this case is a half, this exponent here, right? Let's circle it better. This is your power, this is your exponent here. And it is indeed less than 1. So this is a divergent p-series. So this p-series is a divergent series. I found a series that I already know how to analyze its behavior. This is divergent. So now that we found the series that we already know its behavior, let us apply the limit comparison test. The limit of, okay, it doesn't matter which one you use. You can write the very first general term on the numerator, the second general term on the denominator, or vice versa. Either is fine. So here I'm going to write down my series, which is 2n squared plus 3n divided by square root of, what was on the square root? You have 5 plus n to the 5th. And the second series that we found is 2 divided by square root of n, square root of n, and n goes to infinity. Take the limit as n goes to infinity. This is basically the limit of square root of n times 2n squared plus 3n divided by the multiplication of 2 and square root of 5 plus n to the 5th as n goes to infinity. If you take this limit, this guy is equal to, so with the same process, you can get rid of all of the terms with lower power, or you can basically start dividing and then simplifying it as much as you can. You can divide everything by n to the 5th, or intuitively you can say that, hey, this is basically the same as the limit of 2n squared times square root of n divided by 2 times square root of n to the 5th, but this is nothing but 1 because everything gets cancelled out, 2 and 2, and these are the same, so this limit is equal to 1. By comparison test, by limit comparison test since the limit is 1, it means that both series have the same behavior, but since the summation of 1 divided by, we have the 2 next to it, square root of n starts from 1 to infinity, is divergent. It means that the summation of 2n squared plus 3n divided by square root of 5 plus n to the 5th, n starts from 1 to infinity, also a divergent series. So let us recap. We are checking the convergence and divergence of the following series: the summation of 2n squared plus 3n divided by square root of 5 plus n to the 5th. We can use comparison test, or you can use limit comparison test, whichever you feel comfortable working with. In applying the limit comparison test, we are looking for a series that you already know, you already have some ideas about the behavior of that series, or you have seen it before. When you try to remember that series, and when you have a complicated series like this, try to get rid of all lower power. What do I mean by that? On the numerator, you have 2n squared plus 3n. So you can cancel out 3n. 3n has lower power compared to 2n squared. The same on the denominator. Comparing 5 and n to the 5th, and 5 is just a constant. So n to the 5th is of higher power. You can get rid of this. You can simplify this to 2n squared divided by the square root of n to the 5th. And after simplifying everything, you end up with 2 times square series of 1 divided by square root of n, which is a p series, and it is divergent. Because p is a half is less than 1, you get a divergent series. So you already know the behavior of this series. Now, let us apply the limit comparison test and find the limit of the division between these two. When you find the limit of the division between these two, you end up with 1. Based on limit comparison test, since it is 1, it's finite and positive, these two series have the same behavior. But since the series, p series, 2 times series of 1 over square root of n is divergent, for sure our series in the example is divergent as well.